Hey guys, it's Roya, and today I'll be describing work. Work is the term used to describe a force's action upon a body that causes its displacement, and it only applies to parallel force. This is kind of a difficult concept to understand, so I hope I can explain it to you well. So here we have a really buff dude at the gym, and he is lifting a dumbbell. It doesn't really look like one. Let's see. Here he's lifting a dumbbell, and he lifts it from, let's say, down here to up here. And this is a distance of 2 meters. And let's say that this buff dude only has to exert a force of 10 newtons in order to do so. So this is constant force, and we know that work equals FD, or this might be a new equation to you, but work equals force times distance. And even though force and distance are both vectors, work is actually a scalar, and it's measured in joules. Those are the units. So if we look here, if F equals 10 newtons and D equals 2 meters, then work equals 10 times 2 equals 20 joules. Now that's the work done by the boy lifting the dumbbell. However, if we look at the force diagram, we see that there's an applied force here, but there's also gravity here. Gravity actually does an equal and opposite amount of work in this case because it's working down in the downward direction, and it's moving negative 2 meters because its movement is opposite of the force. So gravity is also doing 20 joules of work in this case. So here's a practice problem for you guys. Here we have Ashley, and she is walking home from school, and she's lugging a wagon full of books. So here she is pulling with a force of 20 newtons, but her angle here is actually 20 degrees. And here she has a D, or a displacement, of 4 meters. Now, I want you to find the work that she does on the wagon, and I also want you to find the work that friction does. Okay, so I hope you've had a chance to try that on your own. Now let's see. W equals FD. However, this is only the parallel force. If we were to take the parallel force here, we'd get F cosine 20 degrees, because this force right here can be split up into this component and that component, and we're only worried about the parallel component. So F cosine 20 degrees is the new force times distance. So if you multiply that all out, you get work equals 75 joules. So that's the work that she does on the wagon. Friction actually does the same amount of work because since this is constant velocity, sorry, this is something that you had to assume, I don't remember if I told you, but it is constant velocity, and therefore the forces are equal in these two directions, and therefore frictional force over here equals the applied force, and so it does the same amount of work, just in the opposite direction.